Hello, I'm Lynn Bondurant. Welcome to episode 8 of our series, 25 Years of Progress. During this 8th program, we cover 1972 and 1973 National Aeronautics and Space Administration events. But first, let's put 1972 into historical focus. 1972 is the year Managua, Nicaragua is struck by an earthquake. 7,000 die and 200,000 are left homeless. And 1972 is a productive year for NASA.
The mysterious red planet Mars is not nearly as puzzling as it used to be, thanks to this spacecraft, Mariner 9. Mariner 9 orbited Mars continuously for more than half a Martian year, probing, sensing, and photographing as the seasons changed below. These are some of the things we've learned. Mars has been geologically active with volcanic mountains. There are indications that free-flowing water may have existed sometime in past Martian history. Observed from above were huge impact craters and wind-blown dunes. The more than 7,000 pictures returned by Mariner have enabled scientists to map the entire Martian surface and pinpoint landing sites for the unmanned Vikings scheduled to soft land there in 1976. Jupiter, 1,000 times larger than Earth, distinguished by glowing yellow-orange and blue-gray stripes. It appears to have its own internal energy source and is so massive that it is almost a small star. We launched a spacecraft toward Jupiter. Called Pioneer 10, it's still 250 million miles away from this largest planet in our solar system. As it flies by Jupiter in late 1973, its cameras and sensors will return the first pictures and data ever recorded at such a close range. This is what the orbiting astronomical observatory named Copernicus looked like before it was launched last August. Equipped with sensitive precision instruments, including a 32-inch diameter telescope, this heaviest of our unmanned spacecraft is studying stars and galaxies to gain a better understanding of how they evolve and eventually die. Now in orbit above the Earth's distorting atmosphere, Copernicus has a clear view of the stars and is returning important new information to astronomers every day. In cooperation with the Italian government, NASA orbited another in the Explorer series of spacecraft. The small astronomy satellite was launched from a platform in the Indian Ocean to study Earth-Sun interactions and especially search for gamma-ray sources. 84 sounding rockets were launched from NASA's Wallops Island station in Virginia and other sites with payloads to study phenomena affecting the Earth's atmosphere. These small, relatively inexpensive rockets are telling us a lot about near-Earth space below the region where satellites orbit. A comprehensive program to study and make better use of our Earth's resources is in full swing. High-altitude planes and the new Earth Resources Technology satellite are returning thousands of high-quality pictures of the Earth. As a result, scientists hope to better understand our planet, its forests, crops, geology, and pollution. A new Nimbus research and development weather satellite is taking the first vertical temperature readings from space through clouds. It is also monitoring a mysterious disappearing current off the west coast of South America and thermally mapping the Earth's surface so geologists can better understand what's happening below the crust. Two commercial communication satellites were launched for the Communications Satellite Corporation. Adding new telephone and television channels, both craft become part of the global communications satellite network. The A in NASA stands for aeronautics, with a wide range of projects underway. For example, this airplane is equipped with a digital computer that was developed for the flight control system of the Apollo lunar lander. Its use in planes of the future should make air travel smoother and safer. Many aeronautical problems are studied in NASA wind tunnels without having to test full-size planes. Engineers can, for instance, test a tail or wing section to destruction. Knowing in advance where structural weaknesses are makes it possible to design out many problems before the first plane is manufactured. To help relieve airport congestion, NASA is test flying short takeoff and landing planes like this one. STOL planes, as they are called, need very little runway to either take off or land, and may play an important role in providing convenient, short-haul intercity transportation. Research is continuing to make presently operating commercial jet aircraft engines quieter, and also to develop the technology for a new, quieter engine. Less noisy takeoff and landing procedures are another area of study. Much of this work is being done by NASA's Lewis Research Center in Cleveland and the Ames Research Center near San Francisco. 14 times the wingless M2 lifting body was dropped over a dry lake desert near the Flight Research Center in California. Craft like the M2 are forerunners of the reusable space shuttle that will fly a space mission, then return to Earth, landing like an airplane. During his visit to Russia, President Nixon signed an agreement with Chairman Kosygin of the USSR to conduct an Earth orbital rendezvous and docking in 1975 between a U.S. and a Russian spacecraft. Engineers from both countries have already begun working out the details of the mission. To help pave the way for the longest Skylab mission next year, astronauts Crippen, Thornton, and Bobko spent 56 days locked in a 20-foot-long altitude chamber at the Manned Spacecraft Center, Houston. The purpose was to collect medical data, which can be compared with that collected from the real Skylab flights. Skylab crew training and spacecraft assembly and testing is also well underway. Skylab will be this country's first space station. It will be used as a platform to study the sun, the Earth, and man himself. Apollo 16, with astronauts Young, Mattingly, and Duke, and Apollo 17 with astronauts Cernan, Evans, and Schmidt, marked the 5th and 6th times Americans landed on the moon. These two flights also concluded the Apollo program. But as astronaut Eugene Cernan said before Apollo 17, it's not the end, but the beginning.
Those are some of the NASA highlights of 1972 as seen by the eye of the camera. Let's put the following year, 1973, in perspective. 1973 is the year high-powered microscopes enable surgery such as reimplantation of severed fingers. And in 1973, NASA compiles a list of varied activities.
Aeronautics and Space, 1973. These were the highlights. This was the year of Skylab. Skylab got off to a shaky start when a heat-deflecting micrometeoroid shield was ripped off during launch, causing the loss of one solar wing and jamming the other. Although in orbit, the big space station was overheating and low on power. People on the ground, however, hastily designed a replacement, an umbrella-like device that would protect the workshop's thin skin from the hot sun. The first crew then used the newly designed sunshade to repair the overheating space station. They also deployed the jammed solar wing. Result, an increase in electrical power and a cooler place to work. And work they did. 3 separate astronaut crews have lived in Skylab for extended periods of time, proving that man can withstand prolonged weightlessness. By training Skylab's onboard telescopes in the direction of the sun, the science of solar astronomy has been extended beyond the limits of Earth-based observations. We're learning more about the sun than ever before. Information that may one day help us use this giant furnace as a means of generating and controlling energy for use on Earth. Using cameras and remote sensors, the crews have accumulated hours and hours of intense observations of the Earth. Observations that have ranged from taking measurements of Hurricane Ellen over the Atlantic Ocean to photographing possible huge new mineral deposits in Nevada. By the time Skylab ends, more than 42,000 pictures of the Earth's surface will have been taken. They called her Arabella the Space Spider. Actually, Arabella was one of several student experiments on Skylab. The question raised by a young high school student from Massachusetts was, can a spider spin a web in the absence of gravity? The answer, as you can see, was yes. Tiny fish were another subject for study. This Buck Roger-like backpack was also tested. The well-dressed spaceman of the future may very well get about like this. American astronauts and Soviet cosmonauts trained this year to prepare for a joint space mission in 1975. The 2 crews will meet and join their spacecraft while in orbit around the Earth. Beyond the rescue capability they will demonstrate, it is hoped the complex project will lead to future international cooperative programs. It's called the Reusable Space Shuttle. Taking off like a rocket and landing like an airplane, it will virtually replace the way we transport manned and unmanned spacecraft into orbit by the early 1980s. To prepare for the shuttle, research and development programs continued to move ahead as high-speed wind tunnels were used to help solve the problems of re-entry. Here, undergoing tests, are special recoverable booster rockets that will be retrieved after launch. Other engineers prepare to make shuttle vibration studies, finding out where the stress areas are. At NASA's Flight Research Center in California, the X-24B lifting body was airdropped several times. The X-24 is developing maneuvering and landing capabilities for future aerospace vehicles like the Space Shuttle. This is an artist's concept of the asteroid belt. A scientific spacecraft, Pioneer 10, spent 210 days passing through the thousands of rocks, sand, and dust that make up the asteroid belt, on its way to this planet, Jupiter. On December 3rd, after traveling 500 million miles from Earth, Pioneer 10 returned close-up pictures and scientific data as it passed within 81,000 miles of the giant planet. Data about its temperature and the makeup of its atmosphere. Mercury, smallest planet in the solar system and closest planet to the sun, so close that it's difficult to observe from Earth. This Mariner spacecraft is on its way there now. After swinging around Venus next February, picking up speed from that planet's gravity, it will be propelled on toward Mercury. On March 29, 1974, as Mariner flies by the tiny planet, its 2 television cameras will return pictures, while other instruments probe in an effort to better understand its makeup. Technicians work around the Radio Astronomy Explorer satellite at the Kennedy Space Center. Its job is to explore the sources of low-frequency radio noise in our galaxy and beyond. Launched into orbit around the moon, it is expected to provide astronomers with a better picture of extraterrestrial radio signals. Work continued in the preparation of Viking, the spacecraft scheduled to land on Mars in 1976. Trying to answer as many questions as possible before landing on the red planet, scientists have been attempting to simulate the Martian atmosphere. Progress is also being made in preparing biological sensing devices to determine if life exists there. For years, NASA has used sounding rockets to probe the region of the Earth's atmosphere just below satellite level, but above the area where balloons return data. This year was no exception, with some 80 launches both here and abroad. Several of the launches were in support of the manned orbiting Skylab. Comet Kohoutek is on its way. Visible between mid-November and late January, it will eventually be as bright or brighter than the famous Halley's Comet of 1910. When Kohoutek reaches its closest point to the Sun on December 28th, it will have completed a journey that began about 2 million years ago. 4 NASA spacecraft, sounding rockets, balloons, Skylab, ground-based observatories, and telescope-carrying aircraft like this will team up to form the most comprehensive comet watch ever planned. Astronomers are eager to determine the elements that make up Kohoutek, elements that should tell us more about the nature and origin of the Sun and other planets. Santa Barbara, California, Louisiana and Mississippi, Cleveland, Ohio. All these places, like many others, have one thing in common. Each was photographed by the Earth Resources Technology satellite orbiting 570 miles overhead. Since being launched in mid-1972, the Earth Resources spacecraft has returned nearly 100,000 pictures of our planet. More specifically, it is proving extremely useful in such applications as land use and timber inventory, crop identification, water pollution, and improved maps. To geologists, this area of California looks like this when the appropriate geologic information is superimposed. Investigators look forward to even more exciting possibilities for operational use in the future. For example, during this past summer, a remote sensing station was tested that can tell when conditions exist for a forest fire to occur. In less than an hour, valuable fire index data was relayed via the Earth Resources satellite to the California Division of Forestry headquarters in Sacramento. The highly successful experiment has important implications for those areas troubled by forest fires. Helping verify images from spacecraft are the U-2 high-altitude Earth survey planes. Flying at altitudes of 65,000 feet, the U-2 has evolved into a sophisticated research tool in its own right. These are just a few of the high-quality pictures returned. Pictures that have spotted smoke from forest fires in California and helped survey the extent of damage done by tree-killing tussock moths in Washington and Oregon. The Lewis Research Center in Cleveland is scene of a program to explore and demonstrate how navigation of the Great Lakes may be extended year-round. Ice maps are made with the help of a reconnaissance plane on loan from the U.S. Army. Its special radar provides detailed images similar to black and white photographs. Another plane records ice surface temperatures. NASA scientists also regularly fly in Coast Guard helicopters equipped with a type of radar that measures ice thickness. To verify these instrument measurements with actual conditions on the ice surface, samples are taken along the flight path. The system is expected to be in use this winter, making it possible to extend the shipping season and potentially saving millions of dollars. NASA's aeronautics program is geared toward improving civil and military aviation, noise abatement, airport congestion, visibility tests, short and vertical takeoff planes, and all aspects of aircraft safety. In great demand are the many simulators that help man work better with his machines. Some simulators use motion to make the pilot's senses believe he is flying. This man-machine integration, as it's called, tries, among other things, to determine the proper roles for humans and computers. Emphasis continues on the rapidly growing class of planes used by individuals or as executive aircraft. Consider the problem of wake turbulence, tornado-like patterns of air that trail behind large jets. These vortices, as they are called, pose a hazard for smaller, lighter-weight aircraft following in their wake. Through laboratory and wind tunnel tests and actual in-flight analysis, NASA is studying ways to break up the whirling air masses, eliminating the danger to smaller planes. A research program is underway to identify acceptable airplane ride qualities. These passengers respond to a variety of vibrations and motions without actually flying. Simulators like this one at the Langley Research Center are used to study passenger response under controlled conditions. The simulator work is correlated with flight tests at the Flight Research Center. Volunteer passengers read, write, eat, and drink, typical passenger activities. During the flight, they evaluate the degree of motion and electronically record their rating. The U.S. Army Flying Crane helicopter is a unique machine. When the helicopter developed excessive vibrations under certain payload conditions, the Army was assisted by NASA in solving the problem. The solution developed involved bonding stiff, lightweight boron epoxy materials to the aluminum frame. The process eliminated the problem and provided a weight saving of 60 pounds besides. So successful has the composite materials program been that test applications are planned for the wing, rudder, and aileron components of large transport aircraft. At the Flight Research Center, test pilots are flying a plane without having to leave the ground. Actually, it's a new way of flight testing advanced aircraft that's both more economical and less hazardous. A typical flight involves air launching a large-scale model from high altitude. A research pilot in a realistically recreated cockpit on the ground, complete with flight controls, flies the remotely piloted craft using computers and television. The television camera is installed in the model where the pilot would normally sit. This view is then transmitted to the test pilot. Since the research pilot on the ground has direct control over the model, he is able to perform high-risk flight maneuvers such as stalls and rolling. At the end of a typical 9-minute test flight, the model is lowered by parachute. In the final stages, it is recovered in midair by a helicopter and brought gently to the ground for reuse. Speed and fuel consumption. These factors have great impact on the design and performance of future aircraft. This Air Force plane, the YF-12, is being test flown to study such things. Other areas of research include heating, flight stability and control, structural dynamics, gust response, and since the plane cruises at 3 times the speed of sound at 75,000 feet, the physics of the Earth's upper atmosphere. Manned spaceflight, space science and applications, aeronautics, and research and development. 1973, a year of significant achievement.
Those are some of NASA's 1973 highlights as seen by the eye of the camera. Next time, we will cover NASA events from 1974 to 1976. I'm Lynn Bondurant.
Roger, Columbia on a roll. Columbia, Houston, your go at 40.